Hello all. Today we are discussing regarding the one of the major topic permutation and combination. Yeah, better you are all know that permutation is nothing but the arrangement and combination is nothing but the selection. So permutation formula is NPR should be equals to n factorial divided by n minus r factorial, and combination is NCR should be equals to n factorial divided by n minus r factorial into r factorial. These things all you know, but before going to this actual topic, let me take a brief introduction regarding how to count, or how to. There are fundamental two basic principles of counting. So there are two principles. Let me take. We have three pencils. Okay, we got it. We have three pencils and we have two pens. So in how many different ways a pencil or a pen, I'm saying in how many different ways a pencil or a pen can be chosen. Okay, let me take how many different ways a pencil can be chosen. There are three pencils, therefore three different ways to choose it. Plus, so there are two different pens we can choose in two different ways. That means a pencil or a pen can be chosen in total five different ways. Got it? We are using the word or, that means we are adding up three different ways of pencils and two different ways of pen. We are adding up. Like only the same three pencils and the same two pens. These are pencils and these are pens can be selected. That means pencil and a pen. We are using the word and. How many ways? There are three different ways to choose the pencil, and means multiplication. Two different ways to choose the pen. That means there are six different ways to choose. So in fundamental theorem of counting actually says that or means you have to add up, and means you have to multiply, or means add, and means you have to multiply. It is the basic fundamental principle. I hope you all got regarding this one. So next one is in permutation. So you all know that permutation is nothing but the arrangement, right? So arrangement of things or objects. Let me take a simple example. So first we will take the arrangement of numbers. Let me take there are five numbers 1, 2, 3, 4, 5. So how many three-digit numbers? How many three-digit numbers can be arranged? Can be made from these five numbers? So the question is there are five numbers 1, 2, 3, 4, 5. How many three-digit numbers can be made from these five numbers? So there are two cases. One is when the numbers are repeated. The numbers are repeated, and the second one is not repeated. Numbers are repeated and not repeated. Let me discuss the first one. So the numbers are repeated. So how many numbers? There are five numbers. I am filling from the unit place. There are five numbers means how many different ways I can fill in the unit place? There are five different ways, right? So there are five numbers. I can fill any number if repetition is allowed. So there are five different ways to fill the unit place. There are five different ways to fill the 10th place. So the repetition is allowed me. I can use the number anytime. So or how many times? As many times as I like. So there are five different ways to place the 100 place. That means 5 into 5 into 5. There are 125 different ways or different digits can be formed from these five numbers, right? When repetition is allowed. Like only, there are one more condition. The same numbers 1, 2, 3, 4, 5. The same numbers when repetition is not allowed. When repetition is not allowed means we have 5 numbers. So for the unit place, if I fill 4, I fill the number 4, there are 5 different ways. There are 5 numbers. If I fill 4, then remaining only 4 numbers for the 10th place. For the 10th place, there are only 4 numbers. If I fill 3 for the 10th place, there are 4 ways. So then there are only 3 numbers to fill in for the 100th place. That means 3 into 4 into 5. That means 3 into 4 into 5 have only 60 digits. 60 digits can be made without repetition. I hope you all got it. Like only, let me take another example. From the numbers 1, 2, 3, 4, 5, how many odd numbers can be made? Many odd numbers can be made. Let me take 3-digit odd numbers. 3-digit odd number. Let me take like this. So if it is odd, it is not divisible by 2. So for the unit place, we can fill 1, we can fill 3, and we can fill 1, we can fill 3, and also we can fill 5. So how many different choices we have for the unit place? 3 choices for the unit place. For the 10th place, so if I fill 3, it is over. How many choices are there? We have 1, 2, 3, 4 choices for the 10th place. And if I fill 1, how many choices? 1, 2, 3. And 3 choices for the 100th place. That means 3 into 4 into 3. 3 4s are 12. 12 3s are, there are 36 digits. 36 digits that are odd numbers. Like only we can find the even also. There are 36 of even numbers. I hope you all got regarding this one. Like only if I take the arrangement, these are all arrangement of numbers, right? Let me take a word. For example, I'll take the word again. Again. I have taken the word again. So in how many different ways these words can be arranged? How many different ways these words can be arranged? There are 5 letters: A, G, A, I, and N. So there are 5 letters means we can arrange in 5 factorial ways, right? 5 factorial means 5 into 4 into 3 into 2 into 1 way. That means we can arrange the word again in 120 different ways. But there is a repetition of word or letter. The letter A is repeated twice. That means you have to consider if the letter is repeated or not. That means there are 5 different words can be arranged in 5 factorial ways, but repetition of A. There are the number A is repeated twice. That means it is for 2 factorial. That means 5 into 4 into 3 into 2 into 1 over 2 into 1. 2 into 1, 2 into 1 get cancelled. 5 fours are 20. 20 into 3 is 60. So there are 60 ways to arrange the word. So the letters in the word again. Let me take one more example regarding the word. I'll take the word, a simple word. I'll take mobile. So how many letters are there? There are 6 letters, right? So how many different ways can I arrange these 6 letters? So 6 factorial ways. So there is no letter is repeated. M is single or O, only once O, only once I and L and E. So all the letters appears only once. There are 6 different ways. That means 6 factorial ways. Therefore, there are 720 different ways to arrange the letters in the word mobile. Okay. So this is about the arrangement of words and letters. So this is about arrangement. Let me take one more example. Let me take the word as I write Mississippi. I have taken the word as Mississippi. Okay. So in how many different ways these letters can be arranged? So total how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total 11 letters are there. So it can be arranged in 11 factorial ways over or divided by. So how many letters are repeated? Yes, repeated for 2 times here, 2 times here. That means we have to divide by 4 factorial ways. Like only I can be repeated 2, 3 and 4 times. 4 factorial and p repeated twice divided by 2 factorial. So the letters in the word Mississippi can be arranged in 11 factorial divided by 4 factorial into 4 factorial into 2 factorial different ways. We can simplify it. So you'll get the answer. That is the arrangement of the words, arrangement of the letters in the word Mississippi. So this is about permutation. So in permutation, we can find the basic principle of fundamental principle of counting, that is addition and multiplication. Like only we can use the numbers, arrangement of numbers and the arrangement of letters in the word. Let me move to the topic. Next one is combination. Combination. So combination is nothing but it is the selection. Combination is nothing but selection. Let me take like, so combination is selection. So for example, there are four different pens. There are four different pens. So one is, we take blue, then green, then red, and also yellow. Okay. So there are four different pens. Okay. I have to select two pens. What is the number of ways I can select two pens? Either I select blue and green, or either I will select red or white, or I can select blue and white. So I can select in different. So this can be easily calculated by combination. How many different pens are there? There are four pens. How many I have to select? There are two. NC 2. You have to select two pens out of four pens. It can be denoted as 4C2. You have to select two pens out of four pens. Okay. So the formula for NCR, it is like NCR. NCR is nothing but n factorial divided by n minus r factorial into r factorial. If we substitute the value, it is 4 factorial over 4 minus 2 factorial into 2 factorial. If we simplify it, 4 into 3 into 2 into 1 over 4 minus 2 is 2. 2 factorial is nothing but 2 into 1. Again, 2 factorial is nothing but 2 into 1. This 2 into 1, this 2 into 1 get cancelled. 2 1s are, 2 2s are, 2 3s are. There are 6 different ways to select two pens. Let me take. I hope you all got it. Let me take one more example. So, for example, I have 5 black balls, and 2 blue balls. I have 5 black balls and 2 blue balls. So I have to select 2 black balls. What is the combination is? So we can use 5 out of 5. We have to choose 2. And like only out of 2 blue balls, we have to choose 1. That means 5C2. That means we are selecting 2 black balls out of 5 black balls into, we are selecting 2 blue balls out of, we are selecting only 1 blue ball out of 2 blue balls. So what is the formula? So I hope you got it. Okay. So it is 5C2 into 2C1. 5C2 is nothing but 5 factorial divided by 5 minus 2 factorial into 2 factorial is multiplied with 2 factorial divided by 2 minus 1 factorial into 1 factorial. So if we simplify, 5 into 4 into 3 factorial divided by 5 minus 3 is, sorry, 5 minus 2 is 3 factorial into 2 into 1. These 3 and these 3 factorial get cancelled. 2 factorial is 2 into 1 divided by 2 minus 1 is 1. 1 factorial is always 1. 2 ones are 2 twos are. 5 twos I will get 10 into here 2. You will get 20 different ways. There are 20 different ways to choose 2 black balls and 1 blue ball. I hope you all got regarding this one. So next one is, so the number of arrangement of different things in at least one way. So there is a formula for that. That means T is nothing but if you are selecting at least one thing, NC0, NC1 and NC2 and so on up to NCn, it should be equal to 2 power n. So at least once means this can be neglected or this can be deleted. That means NC1 value is always 1. So NC1 is 1. So if you shift this to the right hand side, so number of times at least one item selected is the important one. The number of times at least one item can be selected is 2 power n minus 1. It is the formula. So number of times, number of ways at least one item can be selected can be represented by the formula of 2 power n minus 1. And we have also formula for the dearrangement of the dearrangements. So dearrangement means, so there are n different distinct objects are there. So n different objects cannot occupy their original places. For example, there are 5 envelopes. There are 5 envelopes. There are 5 envelopes. Look here. There are 5 envelopes. They have to post a letter for these 5 envelopes. So we can fill these 5 envelopes for the correct letters. So this can be filled with one letter, this can be filled, this can be filled, this can be filled, and this all can be filled with the right letter. With the right letter. So it is the normal arrangement. So it is the normal arrangement. So filling with the right letter for the right envelope. So we want to fill. So we want to fill for 5 different letters. For example, so we want to fill the wrong letters. So we want to fill the wrong letters for all the envelopes. You have to fill the wrong envelope. So wrong letters for all the envelopes. It is called as dearrangement. So the opposite of arrangement. Arrangement is normal arrangement. So dearrangement is the normal. That means it cannot occupy the original places. The formula is n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 over 4 factorial plus so on up to minus 1 power n into 1 by n factorial. It is the formula of dearrangement. Dearrangement is nothing but the wrong arrangement. Wrong arrangement is nothing but wrong arrangement. That means we have to fill the right, the original places cannot be occupied with the object is called as dearrangement. Okay, it is regarding the dearrangement. So next one is we have to solve regarding a simple example. So let me take, there are 8 men and 4 women. There are 8 men and 4 women. They have to make a committee regarding, we have to form a committee of 3 men and 2 women. How many committee we have to make? So there are 8 men and 4 women. So we have to form a committee of 5 members containing 3 men and 2 women. We can form, let me take, so there are 8 men and many women's, 4 women's, right? 4 women's. We have to pick out of 8 men's, we have to pick 3 men's. Out of 4 women, we have to pick 2 women, right? So the arrangement is out of 8, you have to select only 3 multiplied with out of 4, you have to take only 2, right? Out of 8 men, you have to select any 3. Out of 4 women, you have to take any 2. So if you solve this one, you get 8 factorial divided by 8 minus 3. It is 5 factorial into 3 factorial multiplied with 4 factorial divided by 4 minus 2 is 2 factorial into 2 factorial, right? If we simplify it, so if we simplify it, okay, 8 factorial can be written as 8 into 7 into 6 into 5 factorial divided by 5 factorial into 3 into 2 into 1 multiplied with here 4 factorial 4 into 3 into 2 factorial divided by 2 factorial into 2 into 1. This 2 factorial and 5 factorial get cancelled. 2 ones are 2 twos are, so 2 threes are will get 6. Like only 3 twos are 6 and 6 get cancelled. 8 sevens are will get 56. 56 multiplied by 6. 6 6 are 36, 3 is carry. 6 5 are 30, 33. There are 336 different committees containing 5 members. There are 336 different committees can be made by using these. So by using 8 men, by using 3 men and 2 women, we can find 336 different committees. So next one is, so it comes under circular arrangement. Circular arrangement. So circular arrangement is nothing but if you are arranging in a circle or you have to dine in a circle, the arrangement changes. For example, n different objects can be arranged in n factorial ways, right? For example, if you are arranging n different ways, n different objects, you are arranging in n factorial ways. For in the circular arrangement, it cannot going to happen. Let me take. So for the circular arrangement, so we'll use if there are n objects, it can be arranged in n minus 1 factorial ways. So n objects can be arranged in n minus 1 factorial ways. For example, if I have 6 members can be dined, or 6 members have to take the dinner. 6 members have to take dinner. So this is 1, 2, 3, 4, 5, and 6. 6 members can be dined in a circular table that can be arranged in 6 minus 1 factorial. 6 minus 1 factorial means they can be arranged in 120 different ways, not 720. It should not equal to 6 factorial. 6 factorial 720, it should not equal to 6 factorial. It should be equal to 6 minus 1 factorial. So it is equal to 120. Like only if 5 members can be arranged in the circular table, it is 5 minus 1 factorial, that means 4 factorial. 4 factorial is nothing but 24, right? It is n minus 1 factorial for the circular arrangement. For the normal arrangement, it is n factorial. So we have made the circular arrangement, right? So next we will move to the questions. This is the brief introduction of the chapter permutation and combination. You all studied regarding this one, permutation and combination, but This is regarding the brief introduction. So for the next, we will solve the questions regarding the permutation and combination.